Okay, in this exercise, we're going to see how to use GMS to set up models that represent various details that we've been seeing in alluvial aquifers as part of the lecture. And in particular, we're going to see how to generate the hydraulic head fields that results from recharge from uplands, a tributary, a change in gradient along the stream, and a clay lens. So here's the base map that we're going to use. And for this model, we'll use the complete aquifer. Last time we just split the aquifer in two, right down along the center line here. But we'll use the complete one in this case. And what we'll do is assume that these are no-flow boundaries. Here's a constant head boundary, and here's the stream. It'll go from 0 to 10 meters. There's a tributary off to the side here. There'll be recharge from uplands that comes in here. And this will be a clay layer. And this will be a point where the gradient changes. Okay, the file where this is located is called this here, and it should be posted on Blackboard or on the model gallery. So let's go over to the GMS model, and the first thing we'll do is import the base map file. Takes just a few seconds here to load. Should be coming along here any second. There we go. So we've got to register it. We'll drag these little indicators to the corners. So 1 is up at x is 0, y is 2000, and point 2 is at 0, 0, and point 3 is x is 7000, and y is 0. Okay, so there's our base map. And now what we've got to do is add a conceptual model. Okay, so this we'll call problem 2A. Some coverages to this. Start off with the boundary. And that will be, check that to define the model boundary. And hit OK. And then we'll duplicate that. And I'm going to rename this properties. Let's just call it K. And what I'm going to do is set the coverage up. I'm going to put horizontal K and 2 anisotropies in this coverage. And then put in another one that's the, well, let's just copy it. And this will be recharge. So we'll select the coverage as recharge. And actually, let's go back to K and select the coverage here. So I'm going to make this model a 5-layer model. So let's just put 5 in there now so we don't forget about it later on. So this means that this will define the K. At first it will be just homogeneous, and we'll define it by entering values in here and the attributes for all the different layers that we'll put in. Okay, and of course we'll need a coverage, that is the stream. And this will be the constant boundary, and it will be up in the first layer. Okay, so that's all we need to get started here. We'll go here to the boundary, and well, actually, I guess what we need to do here is put in the boundary. And build that polygon. And probably would have been a good idea to have, yeah, what I'm going to do is I'm going to just delete this guy, this K, and this recharge. I'm just going to copy this boundary and just basically repeat what I did, but I'm going to copy the polygon just to make it easier. So this will be K, and now we can go in here and select the horizontal K, the horizontal and vertical anisotropy for all the layers. And now we can just go ahead and set up the attribute table. Go to polygons. And we'll set it as 1e to the minus 4. So this is a little bit lower, one order of magnitude lower conductivity than what we used last time. And we'll just make it isotropic for now. And now we can copy this. And this will be recharge. So I just did this so that I didn't have to go and redraw the polygon, but I need to make sure to change the coverage to select recharge, and I'll just have the recharge apply to layer 1, although that's what happens by default. And that all looks good, and then I can just go here and select the attribute and go to polygon, where we can set the recharge equal to 1e to the minus 8. Oops. And now we need to put in the stream. So the stream will be an arc, and we'll draw an arc here. And another arc we'll draw over here. Move that into that guy a little bit so that it's straight. Okay. Now we need to select the line, select the arc. So click on that and go here to specify head, and here to double click on that and select specify head. Now we've defined these arcs as specify heads. This is kind of the same as what you do up here for build polygons. And now we can go here to select points, nodes, and define the hydraulic head. We'll set that to be 10 meters at that end and this end. The default is 0, so we should be good for all of these. Okay, that looks good. Okay, so now looks like we need a grid. So we'll go and add in a grid frame, and select arrow, and we'll move it around to cover our model. Okay, so now we're going to go from grid frame to a grid itself, and that we can do right here, map to 3D grid. Click on that, and I'm going to have the X dimension be, keep that default, but I'm going to make it 140 cells. The Y will be 2,000 units. I'll keep all of that, and I'll make it 40 cells. So there'll be 50 by 50 meters in plan view, and then I'll make this minus 15 is the origin, and I'll make it 15 units thick. Actually, let's make it a little bit thicker. We'll make it 20 units thick. It started at minus 20, so the top will be at 0, and we'll have 5 cells, so 5 layers in the vertical direction. So we hit OK. And that's what our grid looks like. You can look at it in plan view and see it's really very thin. So maybe now we can amplify give some vertical exaggeration so we can see it. And there it is in vertical section. Okay. So that looks pretty good. Now we're going to select grid, right click, and add in new mod flow. This is all pretty much following the procedures that we've done before. And so I'll hit OK. And the mod flow is set up. And now we should be able to take this. This is describing the model. Here is our mod flow simulation, and now we'll translate from the map that we've created to the mod flow file. And we should see a change. We should see a change right here, as the boundary conditions are written. So one thing that I'll point out is if you put in the boundary over here, and if you're not careful, one of the things that you can do is have this line go off the edge. So if you were drawing a stream and you weren't really careful, you could do something like this. Let's go and select the endpoint right there. I actually did this while I was setting, but just didn't really notice it, and it went like that. Okay, and so let's take a look. We go and translate this over into a mod flow file. And now you see these little symbols here that are marking the constant head boundary. They set up a constant head boundary here because the line that we drew is contained in these cells. But here it goes out of the cells, and we just don't have the boundary. So you just need to be careful that the line does indeed stay within the grid, and just check and make sure that you are setting it up the way you think you are. Okay, so this looks pretty good. Let's go ahead and try running this and see how this works. So we have to set up we have to save this thing, and I'll call this let's call it HW homework problem 2A. Okay, so there's the results, and just like last time, I think we want to clean this up a little bit. It'll look better if we take off these flooded cells, and if we, for now anyway, I think let's not display the grid, so the cell edges, and let's change this contour option to this color fill and layer. So it looks pretty good. We've got some nice gradients going towards the stream as well as going in the downstream direction. So this is really looking like the kind of thing that we're expecting from a gaining stream. Okay, so this is our baseline. This is pretty much what we set up last time. And now what we want to do is, using this as a starting point, we want to try changing some things and take a look at the effects of these changes. Okay, so what I'm going to do is I'm going to save this model, and then I'm going to change the name of it. And by doing that, I can change the name and I can create multiple setups of a model within this same file. And so by doing that, I'll be able to go back and take a look at this model as a reference. Okay, so that's pretty convenient to try to evaluate the effects of changes. So it's pretty straightforward to do that. What I'm going to do is save this one, and then I'm going to save it again and call it 2A, and I'm going to just call it trib, because what I'll do now is add this tributary. Okay, so to do that, what I'm going to do is, first of all, I'll turn off these that display, and so I can see the underlying base map. Just click that, uncheck that box there, and now I'm going to add a new coverage that will be another stream channel, which I'll put as a constant head battery in the upper layer. So we'll call this tributary. So put in the arc, and then I'll select that arc. This specified head, and then go and select the endpoints and put those down as 20 meters for one side, and 16 meters the other side. These are the elevations of the stream going along the floodplain. Okay, so that should be it. And we need to write this to mod flow, create the mod flow files, and then run it. Excellent. What we have to do first is check that, and now we'll create the mod flow files, and now we'll run it. And we'll save it, but remember we've changed the name, so we have a new name now. So we're good. We do want to save it under that name. And actually I just noticed right here, see those purple diamonds? Those are the constant head boundaries that are the stream, so that's good. It's finished. We can close it and import the results, and there we go. Okay. So there's the effect of this tributary, and you can see it's this local mound here. There's a little mound, and then you can see this is a high in the overall hydraulic head field. You can see that we would have flow going perpendicular to these contours if everything is isotropic. So the stream here is losing and flowing into the aquifer, and we have flow away from the stream as a result. So that's what we expect, and indeed we've seen places in the maps of the aquifers that we've talked about in class that look like this. Okay, so there's a tributary. Let's go and try including recharge from uplands. So what I'll do is I'm going to save this, and then I'm going to save as, and change the name to recharge uplands. Up. So I want to turn off this tributary. If I uncheck it, then the line that I drew is no longer shown. But in order to make so that it no longer is active, a good way of doing that is just go and check this box here. And so now when I go and if I go and write the modflow files, this will no longer be present. So we no longer have the constant head boundary representing that stream. In order to do the recharge from the uplands, what I'll do is add a new coverage. And so now I've got to draw the region where we have upland recharge, and you can see that it's the pink region here. So draw that in. To build polygons. And what's the conceptual model here is that down here on the below this area is uplands, and so we have overland flow or subsurface storm flow moving down slope, and it discharges here right at this point where the slope meets this alluvial aquifer, or perhaps it just remains in the subsurface, but that downslope flow discharges to the aquifer along this strip, and we're considering it to be a recharge, and we're going to represent it as a flux. So let's see, we did this, we built the polygons, and now we can go and set up the attribute table by selecting polygon here. And we give it a recharge rate. Okay, well our distributed recharge was 1 e to the minus 8. Let's make this 5 e to the minus 8. And we'll hit map to modflow. Okay, so now we've written the modflow files, but we really need to check out and see what we've done, okay? And I would urge you to do this regularly. Even if you think you know what should be happening, you should check and make sure that it really is happening, okay? So let's go and take a look at the recharge rate. Well, actually, to turn this back on. So there's the recharge rate that we've created. There's red here that's 10 e to the minus 9, e to the minus 8, which is good. And then this blue looks like, I don't know, 5 or 6 e to the minus 8. So it's hard to tell for sure just what that value is. So let's go in and take a look at the file. Okay, so here's that recharge that we just put in. I don't know if you can read it, but it says 6 e to the minus 8. Okay, so recall that we put in 5 e to the minus 8, and what we're getting here is 6 e to the minus 8. And the reason for that is that there are two regions that are where we're specifying recharge that overlap. The distributed recharge that's specified everywhere, and then this new upland recharge that is only specified down at the bottom of the model. And they overlap, and so what happens in that case is they're added together. Okay, so that's going to be an important thing to keep in mind. They're added together. So in fact, we don't have, if we wanted to specify 5 e to the minus 8, that's not what we have. We have, in fact, 6. So it'll be important to keep this in mind if you want to have multiple overlapping recharges, because you just need to keep in mind that whatever is, that basically these two fields are added together. Okay, so what I think we should do, since we want 5, we should go back here and the attribute table and put in 4. That'll give us a total of 5. And so we can map this. And now we can run it. So now we've got the results here, and what we can see now the results of, or the effect of this upland recharge. We see on this side, where there is no upland recharge, this contour is right here, and here it's further downstream. So there's a steeper gradient here. You can see these contours are closer together than they are over here. So there's more flow going in this direction as a result of this upland recharge that's coming in from the side. So that's really the kind of effect that we would expect, and we see it manifesting itself. So now what I'd like to do is how we can go and use these other files that we've created. Because if we go and look up here, these are the outputs from the tributary model. So if we wanted to check those out, we can switch back to it and get the tributary model. And this is the baseline model without anything. So we could switch back and forth and check out these different effects and compare the results and so on. Okay, so that'll be convenient when we're trying to run numerical experiments and evaluate various different effects. Okay, so we have one more effect that we want to try and set up. So I'm going to save this, and I'm going to change the name to Lake Clay. Actually, I guess we have 2 more effects. We'll do Lake Clay first. And turn this off. So what we're going to say is this is a lake clay. It will be in the first layer and in the second layer. So the boundary that represents the stream is in the first layer. So what we'll do is assume that this clay is in the first layer and the stream cuts through it in the first layer, but it also underlays the stream in the second layer. Okay, so what we've got to do is represent this as a low conductivity layer and also a place where the recharge has been diminished, because it won't be, if this is a lake clay, there won't be much recharge getting into this clay compared to the sand over here. Okay, so we can do this by going and putting in new coverage, and the coverage will put in recharge rate, the K, horizontal K, and the anisotropy. Lake clay, call it, and it'll be defined as the first 2 layers. Okay, so hit OK, and now we draw out this region. Build the polygon. Right-click on the lake clay, go to the attribute table, select the polygon, and now we have all these attributes we can figure out. Okay, so the recharge rate. Let's just say that the recharge rate here is 0. No recharge gets through. So what we have to do here is remember that we're going to add together this recharge and the recharge that we have distributed everywhere. So the easiest thing to do is just to make this negative. 1e to the minus 8. Okay. Horizontal k. The aquifer was 10 to the minus 4. A clay, it could be easily 1 to the minus 8. E to the minus 8. And then we'll also make it isotropic. Okay. So that should set it up. We're gonna have to check this. So let's map it to the mod flow. Let's turn this on first. Let's map it to mod flow. And then let's go and check the recharge rate. Okay. Well, I see that we've got this upland recharge still on. I don't think we really want to do that, so I'm going to turn that off. Go uncheck that. And I'm going to rewrite it to mod flow. Let's check out the recharge. Okay, so here's blue, which is 1 e to the minus 8, and then red is 0 on the plot. That looks good, but you want to check it just to make sure and check the numbers. So we go along, and there's the zone where we have 0 recharge. Okay, so that's set up right. Now let's check the connectivity as well. Okay, so there's connectivity, and blue is 10 to the minus 4, and this is 9 e to the minus 9. Okay, so that looks good. And let's check and make sure that we've changed the connectivity in the right layers. So this is layer 1 that we're viewing, but we can scroll up here to, there's layer 2. It's the same, and then layer 3, layer 3 is back the same properties as the aquifer. So that's good, that's what we want. So let's go ahead and run this. Okay, so there's the results. We're in layer 3. So this is down in the aquifer. We're not really in the lake clay. And what we see is that as we get up to the layer is right here. I can see the boundary of it. And when we get up here, right at the edge of the layer, we have this contour that becomes quite sharp and quite a, we've got the gradient pointing towards the stream and not really downstream at all. So the flow is very rapid this way compared to the down gradient flow. But now, once we get underneath this clay, we see that the gradient is going in this direction, down the parallel to the stream. So what this is telling us is that the flow here is going parallel to the stream, but it's not going towards the stream. The stream is not gaining in this part of the aquifer as a result of this low permeability layer that is overlying the layer that we're in now. Remember, we're in layer 3. Okay, so this makes sense, I think. This is the effect that we have inferred occurs when there's a low permeability layer. And now we've confirmed that and shown that, you put in low permeability layer between the stream and aquifer, it isolates it, and we get this head distribution that reflects this isolation. If we go up in shallower layers, you can see that we do get some, essentially here, this is in the clay itself. And we have a similar pattern. We've got very steep gradients right here. That's because we're requiring the head gradient in the aquifer to be equal to the head of the stream. And so they're very steep gradients right here because of the low permeability in the clay itself. So that, I think, is consistent with our conceptualization of what a low permeability layer would be like. We could try varying the conductivity of the layer and see how much of a change is required to really have a significant effect, or change the shape of the layer. A variety of other things could be done to evaluate various options in kind of a numerical experiment type approach. But what we'll do right now is continue on. We'll save this guy and continue on with our last example, where we change the head in the stream. So save this as another name. Let's call it gradient grad change. Okay. All right. So what I'm going to do in this case is go to lake clay, and I'm going to go to coverage setup and turn all this stuff off. So we get rid of that lake clay, and I'm going to turn off the plot so I can see this. All right, so what I'm going to do is change the gradient in this stream. Right now it's just linear from this point to that point, but let's say there's an impoundment right here, okay, a dam, or something that's blocking the flow. And so in an idealized case, it would be a perfect impoundment, and the head at this point would be equal to the head there, and then the head would drop very rapidly, and there would be some much lower head here. So let's say that, and let's say this is at a head of 10, and this is at a head of 1, and then there would be some gradient from 1 to 0 along this line. Okay, so the way we'll do that is to put some vertices and then change them to nodes along this line. So let's select the stream, and we'll create vertices. Click there, and click there. So we put vertices along that line, and then we'll go to select vertices, and we'll select that vertex, or vertex, and then we'll go and use this function that maps the vertex to the node. The node is what will allow us to control the hydraulic head. We'll do the same thing here. Vertex to node, and then we'll go here and select node editing, and select that, click on it, and we'll change the head here to 10, and do the same thing here and change the head to 1. Okay, so there's our impoundment, and that should be all we need to do. Let's map it over to ModFlow, run it, and turn the results back on. Okay, so here's the results. You can see that things have gotten really compressed. Well, there's a lot of action going on right here. This is where the impoundment is. The hydraulic head is, we've got very steep gradients, or we've got the head gradient is going perpendicular to the stream here. Very little downstream gradient, but that makes sense because this is all at the same head. There's a big step down in head right here, and we can see that there's a steep gradient in the heads in the aquifer as well. What we get is that you see right here and right here, these are this one here, this contour, that's indicating a losing stretch on the aquifer. So we've got a component of the head gradient indicating flow in this direction and in that direction. Okay, so we've got very much of a gaining region right here, and then this is a losing region. It's gaining back here, so we've got water leaving the stream, going around, and coming back in. Okay, that makes sense to happen in impoundments, but the same thing can happen just due to more subtle changes in gradient along a stream. And if you go and do some numerical experiments, I think you can convince yourself that that's the case. Okay, so we've seen how to include 4 different effects. We have them all stored here. We can go and take a look at the effect of the lake clay. There it is. We have the effect of the recharge here coming off uplands, and the tributary, and this is our baseline. So we can toggle back and forth and try to understand what each effect is doing. Now, what I want you to do with this exercise is learn how to set up these various different effects. But I also want you to, and I mean, I'm expecting that you can just follow along the video and should have no problems doing that. But what I also want you to do is, once you can use the code to implement these effects, what I want you to do is try varying the settings on the effect and do that as a numerical experiment. And vary the heads or the recharge rates and see how the effect changes as a result of varying the parameter. And use that to try to infer some insight into the particular parameter. One of the things you might do also is compare the effect that you see here, created in an idealized way, to the different maps and cross-sections that we've seen in class. The video or the PowerPoint that I've been using in class is posted on Blackboard, and so you can get those images and compare them to the results of your simulations. So, good luck.